first one was f of x equals x squared plus 4x minus 12. Guys, do you see how we can? Does anybody have trouble putting the squared in? Okay, it's right. You can hit the right here, and you can hit once you go x, and then you hit that, and that'll square it.
Or the caret button, the second 6 on a keypad. You see the caret button? Only thing about the caret button, I don't know if it's the same with the squared button. Do you know how to get out of the squared? Well, that one, that's kind of nice. If you use this squared button, it automatically takes the cursor and it puts it down to the side. If I hit X and then caret 2, I've got to hit my right arrow to get down out of the exponent. You guys see that? Either one's fine.
Okay, so guys, what's nice about this is you can click on these intersections. It'll tell you the answer. Okay, that'll come in handy in a little bit because they're not going to be nice answers. There's going to be some decimals involved. Okay, so what do I write for my answer here, guys? Go back to your, let's go back to A here. Okay, here's what I want you to write, guys. Let's see. Let me erase this. Here's what I want you to write under this. I want you to write this. We're trying to find out what numbers, if any, I can put in for x that will equal 0. Okay? And look on the graph now. Look on your graph. What did you get? We got 2 answers, right? What were they? -6 should go first because it's smallest, then 2. Now, that's not an ordered pair. That's where my parabola hits the x-axis in 2 spots there. Now, guys, look here. What does that mean? Well, guys, if I put 2 in here, let's just put 2. What's 2 squared, guys? What's 4 times 2? What is 4 plus 8? What's 12 minus 12? So that equals 0. That's what I want.
When x is 2, the y value there is 0, right? So do you see how when he wrote equals 0, we're putting 0 in for the y value or the f of x. Now we're not plugging a 0 in for x, plugging 0 in for y. That's the x-axis. This is where the graph crosses the x-axis.
Okay. And if I put -6 in here, and here, what would I get for y? 0. Okay. That's what that means. Okay. So let's look at B. Let's do the same thing, guys. Underneath it, write 2x squared plus 7x minus 4 equals 0. We want to find if there's any values of x that would balance that out. So go ahead and go to Desmos. And we got 2x squared plus 7x minus 4. Okay, make sure you guys use Desmos, and you should get the same parabola that Mr. Westphal graphed. And we just highlighted the zeros, or the what? X-intercepts. So does everybody understand that if it says find the zeros of the graph, it's where it hits the x-axis? Does that make sense? Good. Good talk. All right. Does everybody have that? Is everybody good? Okay. So go to your paper. And what's my answers? X equals what? -4. Was it 0.5 then?
Yeah.
And I'm not a person to write 0.5. I just write 0.5. You can. 0.5 is fine. Does everybody understand what that means? If I would put -4 in for x, it would be 0 for y. Y would come out to be 0, right? All right. All right, why don't you guys try C on your own? C. What's going to happen on the graph parabola that has -3 out in front of the x squared? It's going to do what? It's going to open down. It should. Make sure you guys see that. All right, I'm tired of snow. I'm going to be honest with you. Unless we're going to have another snow day, I want it to stop. You understand what I'm saying, Lord? No. Okay. Oh, no. All right. Is everybody good? Did you graph it? Mm-hmm. Okay, go ahead and let's click on these. Okay, now, is it perfect numbers? No. And that's okay. Most numbers in math are not whole numbers. Okay? Guys, round up hundreds place, 2 places. So what's this one going to be? Be careful here. What would this be to 2 places? Close. What's a 7 tell the 9 to do? Up to what? We go to a 10. So it would be -2.10. -2.10. And then what would the positive 0 be? Samara, what would that be? Hundreds place. No. We already got this one. This one. 1.43. Is everybody good? All right, why don't you guys go ahead and try D. D. What the? Is that not a decimal?
Is it -3? Yeah. Oh, it's -3, not 4. But
yeah, but is that not a decimal there? I can't see what the decimal is. There it is. All right. Guys, sometimes the problem, you can kind of go see over here. You can go closer, zoom out, zoom in. Okay. What's my zeros in this parabola? Bailey, what do you think? First of all, does your parabola look like mine? should, does it? Hang on, sister. What did you put in this? Yeah. Click on that, the highest point. Does that have 0 for an x value? Or y value, excuse me? Guys, that's the closest thing to the, right? Is that hitting the x-axis? No. Does it have a 0? No. Okay, so what do you think my answer is going to be? What are the zeros of this equation? Somebody said it. No solution. Okay, so make sure you guys put that for D. No solution. And if you want to put yourself a little note under there, the parabola does not hit the x-axis. Or the parabola does not cross the x-axis. Now, could there be a time where there's 1, 0? Zacchaeus is saying no.
Yeah.
Now he changed his mind. Okay, so far we've done what? I think 3 examples where there's been 2, right? We just did 1, there's been no solution. Is there a possibility of 1, 0? Zach, what do you think?
The vertex
Is
it's
what?
on the x-axis.
What if the vertex is the only thing hitting the x-axis? Wouldn't that be 1, 0? Does that make sense? Let's do a little. Well, let's just do this. Oh my gosh. Oh my gosh. Right there, right? Obviously it'd be 0. Now it could be slide. If we did parentheses, right? This would be what? X minus 2 over here. Okay. If the vertex is on the x-axis, there's 1, 0. All right, good. All right, what's the next one here? All right, now. This next one's kind of weird. It says solve by graphing. Okay, here's what I want you to do. Let's look at the worksheet here. All right. It's really easy using the Desmos. X squared plus 2x equals 3. Solve by graphing. What you're going to do is you're going to take both sides of the equation and make 2 equations. Okay? So we're going to do this. Whoops. All right. And if we want to call that our first equation, here's our second equation. What's over there, guys? Just what? Okay. Now, what can you tell me? Now, we're going to graph both of these on Desmos here in a second. What is the first one going to be? Y. Now, we're not going to put sub 1, sub 2 on the Desmos. What's y equals x squared plus 2x? What shape is that going to be? Do not graph it yet. What shape is that going to be? You guys should know. Sabrina. Okay, what is that? We've talked about it. We should know what that shape is. It's a U. What's the shape? It's a parabola. Why is it a parabola? Because x is being squared. What is y equals 3? What kind of shape is that going to be, Jonathan? Or Logan, sorry. A straight line compared to a crooked line? I'm just kidding. It's just a line. It's a line, isn't it? So what we're going to have, you're going to graph both of these. We're going to have a parabola and a line. We want to see where they hit. All right, go ahead and do that. So, Remind me to show you guys something after we're done with this one. Was it 3?
Yep.
Oh my heavens. Okay, so what are we going to write for the solution? First of all, did everybody get this? We had a line and a parabola. Everybody get that? Okay, just click on the gray dots where they intersect. So what are we going to write as a solution here? What do you think, Matt?
Would it be like -3, -3, or
We just care about what values, do you think? The y values. Or excuse me, the x values. So we're going to write, just like we did before, okay? We're going to write x equals -3, comma 1. Now make sure you write it. Okay, we're not writing an ordered pair here. Okay, so it's going to be x equals, like a little bracket. What was the first one, guys? -3? And what?
1?
Thank you. Make it look like that so we know it's not an ordered pair. Those are two x values. Okay, why don't you guys try B?
Can I do something real quick?
Sure.
Have you done it where you just graph it like this? I think Desmos can do that. We'll see. So guys, there's the cool thing about this is there's several ways to do it. So when we wrote out x squared plus 2x equals 3, do you guys agree this is one algebra step away from, if we move this to this side, isn't that one algebra step away from this? Do you agree I just subtracted 3 from both sides to get the 0 on the right? So the one Mr. Parker did, we're looking for where they cross. We're looking for where they're equal. Where x squared plus 2x's graph equals the graph of y equals 3. Where they cross. What are we looking for if we graph this one in red? Where this graph hits the x-axis, right? Equals 0. Do you agree they're going to be the same results? Okay? Please listen. Do you understand that? So let me show you. And then I'll show you one more thing. So x squared, so I'm just going to copy this, Control C, Control V, minus 3 equals 0. Now, what do you notice? Hold on, something happened there. Oh, I'm sorry.
0, can you?
Y
You don't even need the y
equals.
equals. That's what's weird.
Yeah. So do you guys see that where this graph, is this the one I just graphed? I wonder if you can change colors. Oh, I'm just going to make it reappear. Do you guys agree that the zeros on the graph I just plotted were the same as the intersection points, the one Mr. Parker did? Right? It's the same results. One, you're looking for where it crosses the x-axis. The other one, you actually set two graphs equal to each other. You want to see where they crossed. Okay? Let me get rid of these for a second. Now, the other cool thing you can do with Desmos, if I typed in the original, x squared plus 2x equals 3. So x squared plus 2x equals 3. What did it give me? It gave me the 2 points where x squared plus 2x equals 3. Now, that graph doesn't help me at all, right? I mean, it's a weird looking graph. But do you see how that would at least give you the solution? If you actually set them equal, type in the original problem. Okay. So there's a couple ways to do this one. Do it in red. You graph that one. You're looking for where it crosses the x-axis. You graph the purple ones. You're looking for where they cross each other. All right. All right. Go ahead and try letter B. Pick one of those methods. I'm actually surprised when I graphed that one. It didn't actually graph the problem.
I wonder why. Because there's an equation there. Well, there's no y or f of x.
Right.
So that had to be y, right?
Yeah. I'm surprised it didn't just get the 2 dots though. You know what I'm saying?
Mm-hmm. Yep. You have to do on the second one. You have to do y equals the top one. You wouldn't have to. That's what's weird.
All right. If you graph both, you're looking for where they cross. Did you get x equals -4 and x equals 2?
You guys good with that?
If you graphed x squared plus 2x minus 8, if you solve it using algebra, so there, then you're actually looking for where that graph crosses the x-axis. You should get the same x values. No matter how you did it, did you get the right answer? Questions on those? Do we need to do more of those?
So.
Think we're good, Mr. Parker?
Those. I think we're good on those. All right. Once you guys turn this over, you guys have all been to football games or watched on TV when a player punts the ball, right? There's the equation. Okay, it's the velocity is 75 feet per second. Okay, there's the equation of it. All right, now go ahead and put this into Desmos. Let's go -16. Let's see, Desmos. And guys, you could put X instead of T. You know what I'm saying? That's fine. You don't have to have T. Plus. I don't know if I can.
look like you're from the future when you do that, Mr. Parker.
Thank you.
Now, what is t measured in this problem, guys? The height is measured in feet, right? What's the time measured in? Right? Seconds.
Mm-hmm. All right, guys. After how many seconds is the football 50 feet above the ground? Well, does it say 50 feet? How can I figure out what is 50 going to be? The y values, aren't the y values 50? Or in feet, right? What can I graph under this thing? Y equals, what do we want our y value to be? So what can I graph under it? Because it's going to be a crazy decimal. Y equals 50. There you go. There's 50 feet. And then we'll be able to get, okay. So what are we going to write? How long is it going to get for that ball to be kicked to get over 50 feet? Well, it's going to hit 50 feet going up. How long does it take? 0.77, right? What's rounded up? 0.77 seconds. Write that in. And then what? 3.92. So it'll be above 50 seconds. Okay, for those, for that time. What's the next question asking? What's the maximum height? What am I going to hit for maximum height? The what of the parabola? It's going to show maximum height, Alexis. What's that called? How high is the football going to go? What am I going to click on? What's that called? Oh my goodness.
Rhymes with Smurtex. Very good. Smurtex.
We just had a huge quiz on that, sister. How high did the football get? Dorian?
2.89.
89.89 what? Feet. That's how high the ball went. 89.89 feet. Now, what am I going to click on to figure out how long it takes after it's kicked for the ball hits the ground? How many seconds? What am I going to click on down here? One of the what? The zeros, right? Yeah. Right there. How long was that ball in the air? What do you think, Luca? How much? 4.71 seconds. Is that a good punt? That's up in the air almost 5 seconds and went 89 feet in the air.
Mm-hmm.
Yeah, that's a really good punt.
Do you guys understand what the graph means?
Because when you see a ball punted, what's it going to happen? Or anything thrown, it's going to usually travel in a what? A parabola. Right? Right? This is what's happening. The ball's kicked. In 2.3 seconds, it got up to 89.89 feet, and then it came down, and in 4.7 seconds, the ball hit the what? It hit the ground.
What height did the ball start out at?
Careful.
When the time was 0, when they started the stopwatch, the time was 0. How high did the ball start off?
2 feet.
2 feet, right? Look, do you see it? Plug in when x or t, right, is 0. 0 plus 0 plus 2. Why did the ball start off 2 feet?
Because they're holding it.
That's when they hit their foot, right? Ready? 2 feet. Goes up. Goes up to 89.89 feet. Comes down. Hits the ground. This is a if you ever go on to calculus and physics or anything like that, like this is actually how things like that are calculated. Okay. A ball gets thrown up in the air, a rocket gets blasted off. All these things are. This is called a position time graph.
You guys good on that one? I think there's a baseball one on the worksheet. Now, the ones at the bottom, I mean, I don't think we have to do them. All you're going to do is plug those two equations into Desmos and find out where they intersect and put the x values where they intersect. Remember, if they don't intersect, it's what? No solution, right? If you have a parabola and a line that comes like right here, doesn't intersect the parabola, there's no solution. All right? All right. We're passing out the homework. Use Desmos. And shouldn't be that bad. Okay, guys, you want to add some up, please?